You know that feeling, right? You're setting up a TV, maybe for a home theater or a display in a shop, and you realize the HDMI cable is it's like 5 feet too short.
Oh, absolutely. The tyranny of the cable. We have all been there.
Yeah,
And it's so frustrating because you can't always just move the screen or, the source.
exactly. And that is what we're digging into today. We're looking at this one piece of hardware that claims to fix all that. It's the NTI ST-IPHD-LC.
Which is a bit of a mouthful.
It is. But the description is what got me. A low-cost HDMI over gigabit IP network range extender.
Right. And I think the mission for this deep dive is to figure out if this little box really does solve that distance problem without, costing a fortune.
Or just creating a whole new set of headaches.
Yeah, exactly.
Okay, so let's get into the mechanics. Usually if I want to run an HDMI cable, say 50 feet, I'm looking at a really thick, really expensive cable. How does this NTI thing change that?
Well, it completely changes the medium. I mean, instead of trying to force a video signal down a copper HDMI wire, which degrades really fast over distance,
Right.
this kit converts the video into data. You have a local unit, that's your transmitter, and a remote unit, your receiver.
Okay. And you connect them with what?
Standard CEC5E or a CT6 Ethernet cable.
Just normal internet cable, the kind of stuff that's probably already in the walls of half the buildings out there?
That is the whole point.
Hmm.
And because Ethernet is built for data over distance, you get this huge range boost. We're talking 330 feet,
Wow.
100 meters, all while still pushing 1080p video and audio.
That is a massive jump from what, maybe 15, 20 feet for a standard HDMI? But I have to think it's got to be complicated. Networking stuff usually means, IP addresses and config screens.
Surprisingly, no. The sources we looked at all highlight that it's basically plug and play. If the transmitter and receiver are on the same subnet, they just find each other automatically.
So it just acts like a really, really long cable. But you mentioned cost. This kind of converter gear isn't usually cheap.
And that's the other big win. The price is around $170.
Yep.
If you've ever tried to buy a reliable 100-foot active HDMI cable, you know that $170 is a bargain. Plus, if the cable ever breaks, you're just replacing a cheap Ethernet cord.
Not a $200 specialty cable. That makes a ton of sense. But okay, this is where my mind goes. If it's network data, can I treat it like network data? Can I just plug this thing into a network switch?
And that is the aha moment right there. Yes, you can. You are not limited to a simple point-to-point connection.
One transmitter to one receiver.
Exactly. You can do point-to-many.
So wait, I can plug the transmitter into a regular switch and then have, what, 10 receivers hooked up to 10 different screens all showing the same thing?
You got it. It is perfect for things like digital signage, a menu board in a restaurant or flight info at an airport. But you do have to be a little careful with the hardware you use.
Ah, okay. I know there's a catch.
It's not really a catch. It's just, networking physics. If you have one source broadcasting to many screens, a simple, cheap, unmanaged switch is fine. It just sort of shouts the data to everyone. Right. But if you have multiple transmitters trying to send different video to different screens all on the same network,
A little chaos.
you get data collisions. It's a mess. For that, you need what's called a managed network switch. It has to support VLANs and something called IGMP.
Okay, hold on. Let's unpack that. What's IGMP actually doing here?
Think of the unmanaged switch, like a guy with a megaphone shouting to the whole room.
Okay.
IGMP is more like a smart switchboard operator. It knows that the data for the football game only needs to go to the screens showing the game, not the ones that are supposed to be showing a spreadsheet.
So it's just efficient traffic control.
Oh.
Got it. The notes also mentioned cascading. Is that related?
It's all about distance. If 330 feet isn't enough for you, you can chain these managed switches together, up to 3 levels deep.
And that gets you what?
Theoretically, up to 1,000 feet from the source.
That's incredible. But let's be real. We are compressing video to squeeze it through an Ethernet cable. There has to be some kind of quality trade-off, right?
Yeah. Oh, for sure. And it's important to set expectations. The device uses MJPEG compression. That keeps the bandwidth manageable. It maxes out at about 80 megabits per second.
Which means, in practice,
It means for a movie or a slideshow, it'll look great. But the sources give a really specific warning. If you're trying to display a PC screen with fine high-res text, like small fonts in a document, the characters can look, and I'm quoting here, noticeably fuzzy.
so it's great for the TV in the lobby, but maybe not for the primary monitor in a control room.
Precisely. And there's also a tiny bit of latency. about 33 milliseconds.
That sounds incredibly fast.
It is. For watching video, you'd never notice.
Yeah.
But if you were, say, a competitive gamer trying to play on it, you would definitely feel that lag.
Okay, so let's put it all together. It's a low-power system, just 3 watts per unit. It's scalable, and it uses cheap, common cabling. It really feels like this just turns video distribution into another IT problem.
It really does. It completely decouples the location of the screen from the location of the source.
Which brings me to a final, kind of wild thought to leave everyone with. If pro video distribution is becoming this simple, as easy as just plugging into an Ethernet port, are we getting close to a future where dedicated video cables like HDMI and DisplayPort just become obsolete relics?
I think for anything over a long distance, we might already be there.